Awesome. Now, for what you guys came here for, we're going to learn some data science. Today, we're going to be using the Pandas library. So, for those of you who were here last week, which I think is most of you, we use NumPy, which is kind of the basic mathematical package in Python. And today, we're going to be looking at Pandas, which is actually built on top of NumPy. And that's a lot more useful for data analysis when you have specifically two dimensions. So if you've ever used Google Sheets or Microsoft Excel, that all works in two dimensions. You have columns and rows. So Pandas has a bunch of tools for processing data in that form. Yeah, and so if you weren't here for the NumPy lecture, don't worry. This is a self-sustaining one, so you don't need to know the NumPy stuff to do this. So yeah, let's get into it. So, well, what is Pandas? There's a couple explanations of where the name came from. No one really agrees. Some say it came from the word panel data, so panda, which is kind of silly. And that is a term that refers to structured data sets used in econometrics, which is just the math side of economics. And then some people also think it means Python data analysis, which also kind of makes sense. Either way, it's meant for basically analyzing data that could be represented in a spreadsheet, except it's not a spreadsheet, it's just done in Python. Cool. So the most important thing to take away is data frames. That's the main data structure that is used in Pandas. So a data frame is a two-dimensional table-like structure. So again, what you see in like Excel or some sort of spreadsheet software. It's really good for cleaning data, transforming it, visualizing it. So if you have maybe a messy data set where some of the values are missing or like they don't make sense, it's really helpful because you can just use Pandas to go in and fix those values and make transformations. Like you can add and subtract columns and all that. You can also visualize. Like there's some packages that we could get into in a future workshop if you like, and that's for visualizing through like a scatter plot or some sort of chart. So this is just a little table comparing NumPy and Pandas. So they have a lot in common because they're both used for representing and manipulating data, but there are some differences. So, for example, in NumPy, as we saw last week, we have integer-based indexing, meaning that like the first element is just zero it, and then the the one element and two, and so on. So each element can be found with a number, whereas in pandas you can actually label it. So by default, if you have a data frame, the rows are kind of just organized by number, but you can also give them names. So, for example, if you wanted to represent, uh, actually, this is a perfect example. You could use this table. You could represent this in pandas. So you would have like this row is called data structure. That one's called indexing, missing values, operations, and then the columns have the names NumPy, pandas, feature, and then these are the values here, the things that actually go inside the data frame. So yeah, this would actually be a valid data frame in pandas. So yeah, instead of integers, we have more options for how to label things. Uh, yeah, so that's the main difference is the way they're indexed. So here's just a little bit of example code for how to make a series in data frame. I forgot to mention series is just a single column of a data frame. So that's like if you are looking through the weather in a bunch of different cities and you want to look at just the temperature or just the humidity or whatever it is, you can just look at the series. So that's just a bunch of values all indexed with integers. So it's basically an array, but it's in Pandas. So the way you can define the series is really similar to how you make a NumPy array. You just define a list, like using Python's square bracket notation to make a list, and then you just run pandas.series with the list, and that gives you a series. And then a data frame is pretty similar, except now we have labeled columns. So, for example, here, data frame has columns name and age. And then the values for the name are Alice, Bob, and Charlie, and the ages are 25, 30, and 35. So if you can kind of imagine that as a like two columns side by side, that's what's going on here. So there's a few ways to read data. Um, the main way, the most efficient way, at least, is from CSV file. So, does anyone know what CSV file is? What it stands for? Besides Kurt? Besides, yeah, yeah, comma separated values. That's right. So it's exactly what it sounds like. It's you just have all of the values. So up here is the header row, so that's the name of the columns. First column is name, first value is Everett, then Ian, then Bella. So yeah, that's it's really just a way you can represent a data frame in a file. So often when you're trying to read a data set, you're going to be given a CSV file, like we'll do in our coding part of this, and you're going to open the CSV file. Pandas has something built in. You don't have to go through and mess with all this. You just tell it open the CSV file as a data frame, and it'll do it. It knows how to convert this into a data frame. So yeah.
If the commas are big with the limiters, how would you represent like a comma inside of it?
Good question. I don't know the answer to that. Yes, if you're using comma as a delimiter, then what happens if one of your strings has a comma? Do you know the answer? The backslash or something? I don't know.
I just heard it. Yeah,
Quotes.
so it's you can just put in quotes.
Oh, okay. No, that's not.
I think that
Yeah.
changes
No, I think you're right about that. Using quotes around something if you want to have a comma. Because I've had data sets before where it had quotes, but it wasn't like the regular quote. It was like the I don't know if you know this, but when you type a quotation mark on an iPhone, it doesn't use the actual quotation mark key. They have their own version of it, so it isn't valid syntax encoding. Like if you try to code on an iPhone for some reason, the quotation marks will not work because it doesn't recognize them as quotes. It recognizes them as something entirely different. So that's a whole different thing. Apple's
there's a little Japanese apostrophe.
Japanese English. That's terrible. Okay, yeah, so don't code on an iPhone. I don't know why you would, but don't. Okay. So yeah, this is just a representation of spreadsheet basically in comma separated value form. If you have a spreadsheet on your computer, you can usually download it as CSV. So if you want to put something into pandas and you don't want to manually write out all the code like we did on the last slide, then you could just do it in a spreadsheet, save it as a CSV, open in pandas. Really simple. After importing pandas, you just do pandas.read underscore CSV and then the name of the file. And then it actually works even if it's a file that's not on your computer. If it's like a URL for a website or a file, you can do that too. So yeah, they make it really easy. For those of you who were here for last week's workshop, I had you guys manually write in all the numbers for NumPy just to get practice doing that. So thankfully, we don't have to do that this week. We'll have Pandas do all the work. Uh, yeah, so with that, it's time to start our coding challenge. So I'm going to link this in the announcements. Okay, so you guys can go ahead to there. It should hopefully prompt you to make a copy. If it doesn't, then please make a copy so it doesn't change the whole thing. Um, yeah, and then I'll just walk through the first few exercises. What's in here? So I'll give you guys a minute to get that pulled up. Uh, yeah. Is anyone having trouble opening up the thing, making a copy? Does it prompt you to make a copy?
It just like lets me add.
Oh,
I don't even make a copy report.
I'm gonna see about that. Oh, okay. Oh, it doesn't have anything. Okay, whatever. If just, I think the sharing permissions are view only, anyways. So just do whatever. Uh, yeah. If y'all got that pulled up, I'm gonna start running through the examples like for the first few, and I'll let you guys run free. And if you want to go ahead, feel free to do so. Yeah. Does anyone need me to wait before getting started? Cool. All right. Oh, you need a little time. How you doing today? Oh, so you were the one who told me about that. Yeah, but I didn't have the membership, so I didn't get the deal. I had to pay the price. Yeah, but I didn't want to. I didn't realize I had to get the membership until like I was at the checkout, and I was like, I'm not going to hold up everything. Anyways, that's not part of the workshop. All right, I'm going to get started. Uh, First thing, make sure you run the first box. You can either click the little uh play button, or you can press Shift Enter. Make sure you run that, or else you're not going to have pandas imported, and nothing's going to work. So definitely don't forget to run that. Might take a second the first time. Uh, Now we're gonna create a series. So remember, series is just a single dimensional data structure. So it's an array basically. So I've already filled in the brackets. These angle bracket or not angle square brackets give you a list. So it just wants the letters from A to F. So I'm gonna write those in. A, B. What comes after C? Does anyone remember? E.
Yeah, I don't think I put it in.
Okay. Okay. This should be pretty simple. Yeah. So it just returns this. Um, Notice how when it prints it out, it gives you like two sets of things parallel. On the left, you have these numbers that you didn't write, it made it up. And on the right, you have your letters A through F. Well, of course, the ones on the left are actually just the indexes or indices. So it's just how you think of an array as having like a zero at the first element and so on. It actually attaches that for you in the series. So it's a little cool. It's not exactly the same as an array. It's got a little extra flavor to it. So yeah, that's fun. What? Oh, this data type. I think that's because the string is type of object. I wonder what happens if I do this. Yeah. So yeah, it's just what kind of values you're putting into it. And I guess it considers a string to just be an object. But if you put like integers in it or floating point numbers, so like decimals, then it'll have a different type. I think you're allowed to mix and match though. Yeah, you can mix and match. That's allowed. Okay, so that's fairly straightforward. Now I'm just gonna um, fill in. Now it's a data frame, so it's just two series stacked with each other with labels. So I'm just making two columns that both have a title. So the first title is name, and I'm just gonna list out some names. Uh, Bob, Jeff, Jeff with a G. Anyone got another name for me? Kurt, Michael, Jackson. Okay. Yeah, so whatever, just whatever names you want. And then ages, again, just be creative, whatever. Just keep in mind they need to be the same length. You need to have the same number of names as you have ages, or else something's not going to match up. Either you have a name that doesn't have an age, which is a problem, or you have an age that doesn't have a name, which is also a problem. So I have one, two, three, four, five names here. So I'm going to make five ages. Let's say Bob is 25, Jeff is 45, Jeff with the G is 105, Kurt is 21, 22, 20? Really? You're 20? Dang. You're a junior, right? Third year. You're only 20. Oh, that makes sense. October.
Yeah, I really want else to do like college.
Damn. Okay. Okay, and then lastly, oh man, we have to fill in this part. Um, yeah, that's you can mix types. You can have integers and strings together. I just forgot to do this. Um, that's right. Yeah. So I define data to be here is actually a dictionary. So who could tell me what a dictionary is in Python or just in programming general? Sure.
Really?
Yeah, go for it.
It's like a key value pair. It's like a hash map.
Okay. So that's true. That's like data structure level. Talking like high level, it's just it's like an array, but instead of being indexed with numbers, you're indexing it with strings usually. So here the dictionary is a pairing from the word name to this list of names, and then from the word age to the list of ages. So these are lists here, like in the purple, the square brackets. In the squiggly brackets, we have a dictionary being defined. And yeah, so you can then turn that dictionary, that's something built into Python, turn the dictionary into a data frame, which lets you do all this pandas stuff with it. So if you don't do that, then you just have to treat it like a normal dictionary, which is not as fun because there's no pandas. Okay, so it'll print it for you if you did it right. This should just say the word data here because data is what we call our dictionary. And yeah, so I'm also gonna try printing data under it to see what we get. So yeah, notice how when we just print data, we get this weird dictionary. It's kind of ugly, right? It's like, how are you gonna read this? This kind of doesn't make sense. It's like, well, how old is Jeff? Well, you gotta see, okay, it's the second one, so you go to the second one here. It's 45. But if you convert it to Pandas data frame, again, you don't actually have to do anything. You just tell it make a data frame, and it makes it so much more readable. You see, what's the row number? So which person is this? What's their name? So again, who is it? And then what's their age right next to it? Much cleaner, much better format. Okay. So this section here, or actually, are there any questions on that so far? What we've done? Okay. This section here does not require you to write any code. It's just kind of displaying some stuff. So this first one is going to get some sales data. It's just made up sales data of different things. Uh, and you can try sales data dot head, and that lists the first n elements. So if you do it just by itself, you get the first five, or you can type in a number. So I want the first 10 of them, so 0 through 9. And it just shows you the head of the data frame or just the first few. Because a data frame in practice, if you're doing AI or the data science stuff, you could end up with, I don't know, like thousands or even millions of different rows. And so you never want to print that out. You never want to look at the whole thing with your own eyes because it's just too much. So if you look at the head, you can kind of get an idea of what this is going to look like. So what are the rows and columns? What are some of the values in it? Maybe if you want to be more comprehensive, you can look at 50 just to get an idea of like how many of them are smartphones or laptops or whatever. So yeah, that's a useful tool for just getting a little sneak peek at a data frame. Okay, and now we can print salesdata.info, which just returns some basic information. It's not super useful unless you really know what all this stuff means. This is just telling you it has 100 entries. So that means that if you go through the whole list, there's 100 different items that were sold. Um, and then it tells you just these other stats about it, what data types there are. So we have two columns that are int64, meaning that they're just integers. And we have two columns that are objects, in this case strings. That's the month and the product. Yeah. And then this, I think this one's more useful, sales data.describe rather than info. Describe will tell you, uh, first of all, the number of rows, which is useful.
It's the SDSU. And then,
Mm,
that's kind
this I don't know how to respond to that. The SCD is standard deviation. So that means you sold 100 things. Uh, the mean price of a thing you sold was about 270, and the standard deviation is 125, meaning, or is that how this data is formatted? Oh, sorry, of units sold. Yeah. The mean number of units sold is 270, roughly. Standard deviation is 125, which means most of your data is between like 100 and 400, roughly. And it has the minimum number, the quartiles, which I think is really helpful. So it tells you how, what's a 25 percentile? So it's like, how many how many units sold would you need to have to be above a quarter of them? Yeah, so you have that for revenue, units sold. It's just kind of more useful. Again, this is just summary data, so it's not super useful when you're doing complex analysis stuff, but when you're just looking at the surface, it's a good thing to look at. Um, you can also do something like this where you take just a portion of the data frame. So here I'm saying only print the sales data where the unit sold is at least 450, meaning as it says, they sold at least 450. So you see all the units sold here is like in the 400s. I could also do it like less than 150 if I want, and that'll show me everything where less than 150 units were sold. So yeah, that's uh that's just kind of something you can do to look at part of your data. If there's only a certain part that you're interested in, or you just want to filter some out, that's really helpful. So you can do this also with revenue, actually. I would say only where revenue is like greater than 50,000. I don't know if that's going to return anything. Oh, where'd I go? Nope, nothing. 20,000? Yeah. Oh, it's a lot. Too much. Still too much. That's better. Yeah, so in the 40,000 range, we have quite a few. Only a certain number that get above 45,000. Cool. So that's just kind of some messing around we can do. We can also see which ones were sold in December. So if we only care how many of each object were sold in December, then this is going to be an important thing to look at. Yeah, so that lets you look for equivalence. Uh, you can also look for just smartphones, smartwatch, whatever. So what I'm doing here in this next part, I'm using LOC. That's so what that does is it only includes the columns product and units sold. So this is like if I don't care about what month it is or what the revenue is, I just want to know how many of each item were sold. I can just tell it basically only include these two columns. Oh, okay. I should not have saved. Whatever. Wanna, um, cool. Another thing we're gonna do is we're going to mess around with changing unit types or data types. So like what we have here is we're changing all the data on how many units were sold from an integer into a float. And there's basically no reason to do this because it'll always be an integer. But let's say you really like floats, you like having a little decimal point, then you can always just change the column. So I'm saying take sales data at units sold. So take the unit sold column and replace it with the same column but replaced with floats. That's all I'm doing here. And then you can also do some stuff with summary data. You can look at a column and then find its mean or its sum or whatever. There's a lot of features for that. And you can also combine different columns. So what I've done here is first I cloned the original sales data so I don't overwrite it. And then I told it to make a new column called revenue per unit sold. meaning like what's the average amount that this thing sold for. These numbers do not look very realistic. I mean, $51 for a tablet or $19 for a tablet, but whatever. This is just made up data. I just asked ChatGPT, give me a random data set. So, uh, yeah, I just told it set this new column to equal the revenue column divided by the unit sold column. So just take each of these numbers divided by these ones. And without pandas, we'd have to go and manually go to the column, loop through the values, divide it, and do all this weird stuff. But in pandas, it's really easy. You just tell it, make this new column and have it be this column divided by that one. Pretty straightforward. Okay. So now that we've done those basics and we have some code that we're working with, we're going to look at a challenge for you guys. So I won't walk through this one, but I'll let you guys work on it on your own. So basically, what I'm going to have you do is use this data set. You don't need to open it yourself, but this is just kind of what it looks like. It's a bunch of cities and a date, and then a temperature reading and a humidity reading. So what you're going to do is you're going to first open it with pandas using there's a code example earlier here, but you just use the pandas feature that opens a CSV file. Literally, you just copy the link and put that into your code. So yeah, you don't need to actually open it. Um, so that's just the first step. You just open it. It should be literally one line of code. And then we're going to explore it. So I'm going to let you guys look around. You can either click the link and look through the data, or you can print out the whole data frame or a part of it and just kind of look through. So like if we look here, something seems off here. This is the temperature reading in New York on March 31st, 2025, which has not happened yet actually. That's interesting. It predicts the future. Um,
It's
but yeah, negative 999 degrees, which is not physically possible. I mean, the coldest temperature something could be is like negative 400 or something Fahrenheit. I don't know, somewhere around there, like with the laws of physics. So clearly, this is not right. It's not going to be negative 999 degrees Fahrenheit in New York on the 31st. So there's also a couple other problems. Like if I just look through right here, what happened? You have a comma, you got two commas here. Like you're missing the city name and the temperature. So this is kind of a useless row. This has no information. It's just a day and a humidity amount. So basically the point of this second, or not even the second, point of the second one is just to look around and see what you notice. Point of the third section is to clean it. So go through, tell it, look through all these columns, and if there's no city name or no temperature or whatever, you can get rid of the row, first of all. That's not always a bad strategy. Although, if there's too much broken data, maybe you'll remove too much of it. So in this case, that'll be fine. You're going to want to tell it, basically look through all the rows. If the row has a missing city name, just forget about it. Just remove it because that's a useless row. Also, if you get a humidity value that is 200%, that is not possible either. The percent has to be less than 100 by definition. So, but with humidity, it's a little different. Do we have to throw away the whole row here? I mean, not really. We have the city, we have the date, we have the temperature, and clearly it was humid. I mean, the day before and after it was 80%. So let's just call it 100. Let's say if you get something absurdly high, let's say it was 100. So what's that? Well, because humidity percentage is defined as the capacity, like the percentage of the capacity of water that could be in the air based on the temperature and air pressure and everything. So by definition, if you had more than 100% humidity, that would not be possible because you can only go up to the limit of how much humidity you have. If you had more, then it would become water. It would not be in the air. Does that make sense? Okay. Yeah. Uh, yeah. So basically, just go through there. Try your best to either remove a row that doesn't make sense or do something with it, like cap out the humidity at 100. There's not much you can do with temperature. Like if it's negative 999, don't just assume that it's like 0 degrees, I mean, probably just get rid of that one. Or actually, better yet, if yeah. Well, humidity just means in the air, how much water is there versus the capacity of like when it will turn into like water droplets. So it's like, I mean, you could say the humidity of water is whatever percent, right? But that's, I don't know. That you're getting into weather science, and I'm not a weather scientist, so I don't really know how to get into this beyond just what I know on a surface level about air humidity. Uh, yeah. But actually, another thing I was going to suggest, I think it's on the Colab document, but if you don't know the temperature, is it might not be good to throw away the whole piece of data. Instead, you can try setting it to the average of that column. So either the average of all temperatures or the average of all temperatures in that city. So if New York has a blank for temperature, you can just look through and say, well, what is it usually in New York? And that way you're not completely getting rid of your data. It's not perfect. Of course, in an ideal world, you'd have a perfect data set with no problems. But you're going to have to deal with problems in real life.
I do think that's like misrepresented.
It is misrepresenting the data. You're absolutely right.
But if you're
Yeah.
not,
Well, the data is already misrepresented in the form that is given. So do with that what you will. Clean it up. Depends on what your purposes are. Point of this exercise is to get some familiarity with pandas and what we're doing. So yeah, and if you're not sure how to do a certain operation, there's a billion resources online because it's a super common library. So feel free to read the documentation. So yeah, you're gonna go through, explore the data, see what you notice, although I already talked about that, I guess. Clean the data, meaning fix it up, make it so there's no oopsies. And then we're gonna do some data analysis and insights. So you can try finding the average temperature for each city, uh, or you can try to find the city with the highest humidity, or find the date with the most extreme temperature variation. So like when is like if you have the high is 110 and the low is 29, like that's a huge difference versus like you woke up and it's 50 degrees and the afternoon is 55. Like it's yeah. You can go through, just mess around with it, see what stats you can find. And then if that wasn't enough for you, you can look around at some advanced tasks. Like you can try to make a new column calculating the feels like temperature, which is based on humidity and temperature. And you can find a formula online for how to do that. I'm sure there's a lot of different ones. You can also look for the hottest days or find which city has the greatest percentage of like days with good weather. So between 50 and 80 degrees or whatever your threshold is. So yeah, but take this one at a time. Just go through the tasks. You can't really do the data analysis until you've cleaned it, or else it's going to give you problems. So yeah, and don't worry if you can't get to the advanced task. That's a bit of a trickier one. So yeah, hopefully it'll keep you busy. And I'll be here for any questions.